Hey guys, welcome to another video about the MacArthur HAT, and this time also with the dAISy HAT. So we will assemble this together and take a look at OpenPlotter. As my PI HAT housing doesn't fit anymore, I have to disassemble my Raspberry from my sailboat. My dAISy PCB, I remove it because there must be the MacArthur in between. I also had to desolder my UART connection. I placed two PCBs on top of the MacArthur HAT, the 12 volt PCB for 12 volt supply and the MPU tilt sensor, and I tried to put the dAISy HAT on top, and there's a gap, so it doesn't fit, and it is a connection to these two PCBs here, so I had to remove them again. With this construction I can't use them, so I tried it without these two PCBs, and now the dAISy HAT works perfectly with distant pieces, which I have from my PI HAT housing, by the way. So it's assembled, and as you can see, the new UART, because I can't attach the UART on my dAISy HAT anymore. However, it is a little pity that these two PCBs, so the 12 volt supply and the tilt sensor, does not fit, or do not fit without a prolongation at least of the pins here. So if we try to get this below that, doesn't work. So yeah, we need to think if we need them. If you need them and you want to assemble both, you need to prolong the pins. So this is how it looks assembled. The dAISy HAT on top. The black distance pieces are from my PI HAT housing. The golden ones are part of the package. There are also golden ones to screw on the two PCBs, which I couldn't mount. And what you see here is my USB to UART converter. I can't use any UART anymore, at least not without missing some other functionalities of the MacArthur HAT, so I decided to add another UART via USB, which I use for a special thing. If you don't need it, you don't need this whole PCB, just that you know why I have this CP2102 PCB here on top. And now let's take a look how to install OpenPlotter on the system. So I'm on the official OpenPlotter page, and there are three versions available. The standard version, a headless version, which just has SSH enabled and remote desktop. I will take this one because then I don't need to connect display directly. And OpenPlotter touchscreen version, quite interesting if you have a DSi touchscreen connected, but I'm going to download this one here. And I take the 64-bit image. And you can use the Raspberry Pi imager, the official one. You just choose your Raspberry model, in this case a 4 here. You take the unzipped and downloaded OpenPlotter version. You just take your SD card and start it. And I will use my settings because here is my Wi-Fi and so on already set up, and a name and so on, and my language. And I just say go. When the validation process is over, we can remove the SD card and start our Raspberry. So if you, like me, want to access remotely the Raspberry, you should take a look on installation, and where is it? Here are the headless options. So either it's not connecting to your Wi-Fi, even if you have set this in your settings on the PI imager, because it is creating an own Wi-Fi. So you can connect wireless to this access point here. So you need the SSID here and the password, and of course you should change it afterwards. And then you find this one here to be the address to connect the remote desktop application, but you can also use openplotter.local. In my case, I just used a wired connection, and it takes an DHCP address additionally to the access point, and I just looked it up which one it took, and then I can connect with remote desktop. And now it's important for remote desktop, you can't use the Windows remote desktop, you need to use real VNC. And I use the real VNC viewer, which is still free of charge. And you can even get this one here as a download for runtime only. So no installation necessary. Just look for this, otherwise it will force you to create accounts and so on. So just take this one. Okay. I know that I used the 14. I am connecting. So it's on the other screen. I will just take this over here. I have now my own password already because I did set this up on the PI imager. And I get a picture here for login. So we log in with our password which we created. And you see OpenPlotter is starting up. So I shall change my Wi-Fi password because this is the default settings, but everything is okay otherwise, and I can close it. So let's change first the SSID password, because otherwise it's always angry with us. So we go to this pencil here and we just enter a new one and save. Okay, it will reboot. So it's back, and let's see if the check is now identifying that we changed the password. So we had no conflict, so now it's also not waiting. Everything is okay now. So next thing I usually would do is, what do we want to install? Yeah, and it's a good question. Oh, we have also updates. Maybe we do the updates first. Show updates. Let's check this. So there are several updates, and we just say install. And I guess I can wait a second. So I had to reboot, and now my system is up to date. And you see there is already something installed. Let's take a look what we want to look at. What I am interested in, of course, let's do first a refresh to see what is installed already. So you see there is a lot installed, but not everything. I think I2C is something I use often, so I will install this one. And I think it could be also interesting for us to use Grafana as a nice dashboard tool, and maybe InfluxDB as a time series database for informations we collected, like from our I2C sensors, but of course also from NMER sources. Maybe not what we will all do today. Okay, maybe it takes a second, so I will just skip this for you. Installation is done. You need to refresh to get the information that this is installed now. What did I say? So there's a lot we can take a look at, but what is the most interesting part? Dashboards is already installed. PyPilot, we could at least check the MPU sensors. Maybe I install this one. So done as well. Another refresh. And maybe we do the same test which we did last time with Node-RED also now to get warm with OpenPlotter with our NMER. So first of all, we have to enable, if we want to use NMER 0183, also here the UART 3 and 5. And for that we use serial 330, which is a cool tool to directly say, okay, we want to use UART3, just say yes. And also we want to use UART5 after next reboot, and we say yes, and wait a second, I will just reboot. After reboot, we get our new two inputs, UART3 and UART5, which are now our NMIR. So we can call this NMIR 01831. Apply. It must be lowercase string and 0 to 8 characters. Okay, lowercase. What is it for? This is 8, right? 4 and 4, but I need 2 of those. So we need. Can I take this one? Is this okay? I think we could just. Also not accepted. Okay, guys. Data type, it is 183. Apply changes. And we call this NMIR2. Apply changes. I also will set the GPS already. This is my GPS mouse. By the way, when you set something wrong, you see it's now yellow. I think these are the 3 colors, but this is a 0183 signal, so we have to set it also to 0183. And on connections, we can take this one and so on and put it to signal K. I will start first. What does my mouse have? I think it's working with 4.8. We can also set it to auto. And now we should see the USB device on signal K, and the device is hopefully getting already GPS data, which we can then send out on this one. So before we continue, I had to change the resolution. So how do you do that? This is the headless resolution. If you go to OpenPlotter, you can also use in the preferences, you can use Raspberry config. This is also, you can also do this by the shell if you have no access anymore. And there you go to display and you set the headless resolution here. And I did, change this now to a higher resolution so that I see enough. So I had to change this. The first one is my UART. This is the GPS mouse. So I just created a second one, removed this one. I set this one here. So the first one is gone, and this one is now in signal K. And I also, so when we go to signal K, it is quite slow here with the remote access. But when you take a look, you can also access this from your PC directly, and we will do this now. Now accessing it on the IP address and the port 3000, and then I can access this via my PC, which is much, much faster. And you can already see in the data browser, or first on the dashboard, that GPS is sending data here. So it's the only one currently sending data. And in the data browser, I can also see some values which I received, the altitude, which is currently calculated the last time. So it's always the last signal, which you can see here, the source or the sentence. And also when I scroll down, the longitude, but I don't want to show you my longitude now. So the GPS is now working as an input here. Okay, so now I did also set the first NMIR port already on signal K, the second I didn't, then my GPS, not my UART, and also UART 0 is still disabled. This is my dAISy HAT, so this is also something we need to enable, but I don't want to reboot, so we do this later. So both are enabled, and when we take a look here, we see that we saw this before in the data browser, GPS is running. What we can do now is we can use our output to send data. Or what we do is, I think we will already enable also the second NMIR. So we see also the input. Wait. So I decided now also to put this one already to signal K. By the way, the baud rate is also working with 38,400. Okay, signal, you can see in the background that signal K has to restart. I think I didn't, did I put already some names on it? Yes, we called it ENMIA 1 and 2. That was the names we had, but not on our UART and USB UART and not on our UART 0. But that is okay. So now we have them both. And what we want to do is the same check which we did last time. We will send data out on ENMIA 1 and receive it on ENMIA 2. And where do we get this data from? We take the data from GPS. So how do we do it? Everything which comes in on GPS 2, because this is an ENMIA 0183 information, will always be automatically saved in an event called ENMIA 0183. So we will do some extra videos talking about signal K and especially about the event handling, but just believe me, the ENMIA 0183 event is always existing. If you get something in, which is ENMIA 0183, you have this event and you can simply put it anywhere you like. And I define this event to be sent as an output event. Apply, and it says connection updated. And when you take a look at the dashboard, you see that there are no events going out. And by the way, also no events going in. And now let's take a look at our dAISy hat. We connected already ENMIA 1 and ENMIA 2, but we don't see anything. So we will restart the server. Okay, now we restart the server. So it's restarting. Take a look in the meantime on the Raspberry itself and especially on the MacArthur LEDs. And you see that we already have outgoing messages on ENMIA 1 and incoming messages on ENMIA 2 because of this configuration. By the way, I'm a little surprised that it's so many messages, but I think it's an easy reason because we said that on ENMIA 1, all ENMIA 0183 messages shall be sent out. And this one here receives messages which are also going to the ENMIA 0183. So they're sent out again. So we have a loop created here. We need to prevent that these messages go into the same output. So we suppress now the ENMIA event. Okay, we restart. And it should have more or less the same speed like our GPS input. So 5, 6 messages and not what we saw before. Let's check if it's now working without this loop. And you can see now this is much less, it's on the same level here. And this is how it should look like. And I turned the video off, but you can believe me that also the LEDs now from the PCB on the MacArthur are flashing much slower. So I'm still thinking why we have 6 or 5 deltas per second here and just 3 here. Not sure though, because it is working in the data browser. You can see this, that all the GPS, so this is our input source for the GPS, and this is what we retrieve via ENMIA 1 on our ENMIA 2 input, so ENMIA 0183 input on our MacArthur HAT. There is a little gap sometimes between the times, so maybe we're losing some data currently. I don't know, but shouldn't bother us too much. Everything is received. So let's assume we don't want to get all the data from the GPS here. So we could, for example, say this VTG sentence, we don't want it, but it's arriving here at ENMIA 2. In this case, we can simply go to our ENMIA 2 and just say we want to ignore the VTG sentence. Apply. And unfortunately it says updating, but you see it's still there, so we have to restart again the server. And we wait until the server is restarted. So I think we are also almost over with our time. You saw what we did last time with Node-RED. We did it this time now with Signal K and OpenPlotter. And it's also a fine solution. You can already see, by the way, that this is less than before, 2 to 5 instead of 3 to 5, or 6 to 2 instead of 6 to 3, because the VTG is now only for the GPS existing, and on EMEA we don't have the VTG anymore. So we suppressed it, and we could suppress any sentence we want on this one here. Yeah, so that's the good and perfect possibility with Signal K. All right, so enough for today. Let's sum this up. PS, I found it and it's now working. So you see both are 3. Why? I ignored 2 sentences. This is GSV and GLL, because these 2 haven't been forwarded. Don't know why. Maybe these 2 sentences are not supported by Signal K and it's filtering them because they are outdated or whatsoever. But it was these 2 sentences which didn't receive or haven't been forwarded to EMEA 2. Okay, just to let you know. Well guys, that's it for today. It was already again a lot of work, or not a lot of work, but the time of our videos over, so we have to do a new one. I think Signal K is worth to take a closer look. The MacArthur HAT is always just a little tool to get what we need. So today we just used it to get out some EMEA 0183 data from our GPS and get it back in again. We will have a solid project later on with our wind. I have to see if I get this with Signal K or if I need Node-RED for that. We will see. There is a lot I want to try, but yeah, step by step. Hope you enjoyed this video. If so, give me a thumb up and see you next time. See you next time.